Okay, today we're going to be looking at sketching this trigonometric function here, sine of inverse cosine of x. And immediately we're going to run into a few issues, one being how are we going to take inverse cosine as an argument? Well, if we try and sketch the shape of inverse cosine, so I have a little graph here and label my axes. And let's try and figure out what our domain is going to be for inverse cosine. So we know the maximum minimal values of cosine is going to be 1 and minus 1. So we start by putting that in our domain in x. So the range now is going to be just those corresponding values. So to get minus 1 from cosine, we need to put in an angle of pi. So that's going to be up here. To get a value of 0 from cos, we got to put in an angle of pi by 2. And to get a value from 1, we need to put in an angle of 0. So the function will look a bit like this. Now, we're going to have to take sine of this, and that's going to be a bit difficult because we'll be fine by taking sine of individual points here, but we're going to struggle by getting the general shape of the curve. So what I would rather do is by looking at the basics of what sine really means. And lower down in school, you were taught that sine of an angle, like an angle theta, is the ratio of the opposite side over the hypotenuse, obviously labeling the adjacent side. Now this is what sine theta would be, op over edge, and cosine would be edge over height. Now, inverse cosine of x is not the angle here. X is actually a ratio of the adjacent and the hypotenuse. If I were to construct a triangle here of triangle with angle theta here, the adjacent side of inverse cosine of x actually refers to a triangle with adjacent side 1 and adjacent side x and hypotenuse 1. Which by Pythagoras of this right angled triangle gives us an opposite side of square root of 1 minus x squared. So if we were to take the sine of this triangle, which is essentially what sine of inverse cosine x would be doing, we'll be taking the ratio of 1 minus x square of 1 minus x squared over 1. Now if we're going to sketch this function, this will end up being y equals square root 1 minus x squared. Now, if we square both sides, we'll get y squared equals 1 minus x squared. Add x squared to both sides, we'll get y squared plus x squared equals 1. And then this is just the shape of a circle with radius 1, center at the origin. But remember, y can only be positive because there's no plus minus behind the square root there. We've only taken the principal square root. So if we were to sketch this function, it would actually just be a semicircle, center the origin, y, x, center the origin, radius 1, and doesn't go beneath the x-axis. That's a full semicircle, but that one. So this would be how the function would look like.